let us go to electrochemical series. What is electrochemical series? Electrochemical series in lower standard books, it is also given as reactivity series. This electrochemical series is just nothing but arrangement of different single electrodes, that is metal, non-metal and some molecular ions, etc., in increasing order of their standard reduction potential SRP, that is E naught. As in every case, as we have seen, the E naught is the significance of E naught value. E naught, what is E naught? E naught is nothing but EMF of a galvanic cell, EMF of a single electrode, EMF of a single electrode at unit concentration of electrolyte, unit concentration means molarity is 1 molar, unit concentration of electrolyte measured at 298 Kelvin and 1 atmospheric pressure condition. The EMF of a single electrode measured at 298 Kelvin and 1 atmospheric pressure by taking unit concentration of electrolyte is what is called E naught. Now, for different elements, E naught values are determined. For different elements, E naught is determined using standard hydrogen electrode as primary reference electrode or any other secondary reference electrode. That is either using calomel electrode or quinhydron electrode, but the standard E naught values are, of course, for all the elements it is determined by using primary reference electrode, right, that is standard hydrogen electrode. So, E naught value of H plus H2 is what always we are saying that it is 0.0 volts. As this being the moderately electronegative, neither highly electronegative nor least electronegative, this is moderately electronegative. So, this is what is taken as a reference and its EMF is taken as considered as 0. Using this, the E naught values of all other elements have been determined. Now, here the electrochemical series is arrangement of all those elements which are in increasing order of their SRP, means starting with the least reduction potential with least value reaches to 0, that is hydrogen, and below this positive values. So, in the electrochemical series, the elements are arranged in increasing order of their increasing order of E naught. So, here what are the observations? Observations made are that strong electropositive metals like alkali, alkaline earth, strong electropositive metals are at the top of the table, hydrogen is middle, with E naught 0, these are having more negative, then followed by less electropositive metals like copper, silver, gold, mercury, etc. Then more electronegative non-metals, and finally halogens, fluorine, last. This is the sequence. So, what are the observations made? First, highly electropositive alkali metals. It starts with lithium, followed by elements like potassium, sodium, magnesium, calcium, aluminum. So, highly electropositive metals, that is alkali metals, followed by few alkaline earth metals, followed by third group metal like aluminum, followed by more electropositive metals in the D block, that is iron, chromium, zinc, followed by hydrogen, that is at the middle, then next followed by copper, silver, mercury, gold, platinum. Highly electropositive, relatively less, moderate, low electropositive, then finally electronegative, iodide, bromide, chloride, fluoride, and in between also we have the oxidizing agents like permanganate, dichromate, all these also in between you will get it. And even for ions, Fe2 plus Fe3 plus or reverse, if it is oxidation, of course Fe3 plus to Fe2 plus is reduction, because here what always we are talking is reduction. And even cerium 3, cerium 4, cerium 3, all these type of ions, non-metals, molecular ions, everything will become in the table. So, this table which arrange the elements are ions, molecular ions or elemental ions in increasing order of their standard reduction potential values is what is called electrochemical series, and these are the observations. What is the use of this electrochemical series? What is the inference that we can draw from this electrochemical series? The inference is the use of this electrochemical series. Now, let us see one by one. Applications of electrochemical series or uses of or inferences of electrochemical series, whatever you call. What we can write is that when elements are arranged in increasing order of E naught values, remember always that, see here whether we are writing in increasing order of SRP or increasing order of SOP, that all important. As earlier, for any element, SOP is minus of SRP, that is always to remember, means E naught Zn2 plus Zn will be equal to minus of E naught Zn Zn2 plus. This value is minus 0.77, this value is plus 0.77 volts. So, here what we are talking is SRP, SOP. So, SRP is minus 0.77. What we are talking is always in increasing order of E naught means SRP. This is for hydrogen, it is 0, this is less than 0. So, as we told earlier that the elements are arranged in increasing order of SRP values. Lithium is the one with least SRP. Lithium is the one with least SRP, that is minus 3.4 volts, followed by other elements. Zinc with moderate SRP with minus 0.77, followed by hydrogen, which is having 0 SRP. Then copper having positive, that is plus 0.34 volts. And last, of course, fluorine. This is some plus 3. So, as you can see, highly electropositive, moderately electropositive, hydrogen, least electropositive, highest electronegative. This is the sequence. From this, what you can understand is the element that comes first, is a better reducing agent, and the element that comes last is a very good oxidizing agent. So, here whatever element that comes over here, elements over here can act as a reducing agents. These elements act as reducing agents, and they can, what you call, they themselves will undergo oxidation or undergo oxidation easily. And these are the elements, they act as good oxidizing agents, as they undergo reduction easily. So, those elements which are at the top, they are good reducing agents. The elements which are at bottom, they are good oxidizing agents. The element at the top can reduce the element at the bottom, and also, so the element at the top can reduce element at the bottom, and elements above hydrogen can replace hydrogen from the acid. For example, Zn plus H2SO4, you can have ZnSO4 plus H2. This is possible, but Cu plus H2SO4, CuSO4 plus H2, this is not possible. So, elements above hydrogen can replace hydrogen from the acid, but elements below hydrogen cannot replace. And also, here what we wrote, the element at the top can reduce the element at the bottom. So, zinc Cu2 plus, this reaction is possible, Zn2 plus Cu. Element at the top will undergo oxidation, reduce the ion to metal, this is possible, but the other way around, Zn2 plus Cu to Zn plus Cu2 plus, this is not possible. So, these are the two very important facts that we can understand from the electrochemical series, right. So, this is very helpful in understanding the possible redox reactions. E naught values will give us a very clear understanding about the possible redox reactions. That is a very important application of this electrochemical series.